You know how dilations work. You know how to dilate a point, hopefully. Now you find me the scale factor. All right, that's today, and how to do constructions. So find me the scale factor. I start out with point A, 3, 4. I did a dilation, and I ended up at 9, 12. What must have been my scale factor? Good news for you guys. If you read through it, where's the center of dilation? Oh, the origin. That's huge because I must have done what to 3, 4 to get 9, 12. Multiplied by the scale factor. Because it's centered at the origin, I must have taken my, whatever it is here, my scale factor, multiplied 3 and got 9, multiplied 4 and got 12. Powerful when you know it's around the origin versus another point. So my scale factor here, what am I multiplying by? Nice and neat here, 9, multiplying by 3. No big deal. Oh, I wish it was that easy, right? Just, oh, it's that number. 9 to 6, 12 to 8 on the next one. 9 to 6, 12 to 8. Well, that's just not a number that's going to pop into our head, some of us. I get it. It's not. All right. If it's not going to pop in your head, let's write a quick equation down to solve. Let me take the x coordinates. 9 times whatever my scale factor is should give me, what's 9 correspond with on point R? 6. All right. Nice little equation I can solve. Divide both sides by your 9. And x equals, I prefer fractions, please. You can leave it 6 over 9. If you want to be a champ and reduce it, go right ahead. 2/3. All right, don't give me 0.6666 repeating. A little cute bar on top. Hey, you and your group, number 3. Go ahead. What's my scale factor on number 3 now? -2 to -10, -3 to -15. And your scale factor here. Here we go. Hook me up. 7. 5. All right, no issues. Ooh, how about a diagram now? Forget the points. How about I just give you a diagram? And you tell me what the scale factor is. Can you read the problem, though, first? Here's the thing. Polygon B is the image. So I'm going from A to B here. Why is that going to be huge? Diagram number 1, am I getting smaller or bigger? Smaller. So no one in the room should be giving me a scale factor bigger than 1 if I'm getting smaller. Keep that in mind. Keep that in mind. And oh, it's centered around the origin. So I don't have to do rise over run from 0, 0. What I can do is the following. Pick a random point on point A. I'll pick this point right here. That's -3, -3. The point it corresponds with in B is -1, -1. What must I multiply the coordinates in A to get B by? Just like we did last problem. See what I turned it into? Last problem. And again, if you're giving me something that's bigger than 1, no, we're getting smaller. We're getting smaller. Oh, don't want to see those again. 18, what are we looking at? 1/3. Good. Hey, if you're writing 3 down, again, it's a reduction, not an enlargement. All right, you and your groups, go ahead. 5 and 6. A to B. A to B. A to B.
Like 35. But realistically, I probably would 30. I could settle for like 30. Compared to my previous tests, which were 70s and 60s. I love Apple. I hope she doesn't count me for not having a good haircut. I just did 2 huge paragraphs that covered everything. That's 2 huge paragraphs. There's like 1 small paragraph on 3 for.
Oh, we're good? All right, here we go.
What?
All right, another minute. Go ahead.
Oh, no. Oh, yeah, that's what it said.
All right, this first one. Going from A to B. Hopefully give me something bigger than 1, right? Bigger than 1 because we're enlarging here. Got a little enlargement going on. Oh, boom, 17. What do you have?
For number 5?
Yeah.
Oh, 2.5.
That's what I thought.
Sorry.
2.5. Anybody have 5 halves? That's also a good one, too, if you left it as 5 halves. I'm good with that. 2.5 is nice. Hopefully you didn't hear what Riley just said. So number 6. 5. 1/3. Not 3, everyone. Not 3. Woo! All right, ABC to A prime, B prime, C prime. Describe the transformation that's performed. Well, are we all, it's a safe bet, it's a dilation. It's getting bigger, right? Dilation, but that's not good enough. Why not? You got to tell me then where's the center and the scale factor. So that's you and your group right now to discuss. Okay, I get it. It's a dilation. Congratulations. But now I need to know a dilation centered at, woo, and a scale factor of, yep. All right, here we go. Dilation centered at, you can fill in the blank with a scale factor of, definitely the scale factor should be bigger than 1, right? We're getting slightly larger here. Where do you think it's centered at? Where's my dilation centered at here? Oh, 10. Origin, yeah, 0, 0. And with a scale factor of, what's it bigger than 1? Scale factor of 2's, 22? 2.5. Now, so I get it. You know, I have 26 students in here today, and I know some of you, wait, whoa, how did they get that so quick? Let's take point B. All right, point B is -2, 1, 2, 3, 4. So -2, -4 I jot down, and then B prime is -5, -10. What you notice is, hey, I'm multiplying -2 and -4 by the same number to get to the image points. If that's the case, it's got to be centered at where? the origin. All right, it's got to be centered at the origin if I'm multiplying by the same. Now, would I really just take that and go with it? No, I'd probably do A prime and C prime just to make sure. All right. Am I ever going to ask one that's never centered at the origin? Probably not. That'd be a little too ridiculous. All right. Mostly going to be centered at the origin. And then explain why they're similar now. Part B, why they're similar. Remember we did congruent? A translation is a rigid motion which preserves distance and angle measure. Ergo, the two are congruent. Let's do the same thing for similar. Except now, how am I going to start it out? What did we perform? All right, here we go. Dilations. Are we going to add in that R rigid's motions part? Nah, that's not true. That's embarrassing. All right, dilations. We're not doing the rigid motions. Do they preserve distance? That's not been put in there. How about preserve angle measure? There we go. Dilations. Preserve angle measure. What's your go-to word today? No, nope. 13, what's your go-to word? Thus. Nice. Nice. Thus. Makes you feel a little smarter than probably most of you are, right? By writing whatever fancy word you want here, right? I throw ergo down. I feel like a boss. I don't know about anybody else. I throw that down at home sometimes. Mrs. Carlino just looks at me like, you're a loser. Let's be real. All right, you ready for the constructions now? All right, grab your straight edge, grab your compass. And really, I'm not going to teach much here. When do you ever? Yeah, I know. Yeah. Because you guys know how to do it. You're going to put your knowledge of dilations and your knowledge of construction so far this year, and we're going to put them to use. We're going to take art, dilate it around O by 1/2. First question, are A, R, and T getting closer to O or further away based on that scale factor? Closer or further away? 10? Closer. How much closer? Half the distance. So let's first start by dilating R. Everyone connect R to O. Show me their distance. Just take your straight edge and connect them. Show me the distance from R to O right now. Show me that distance, please. And what am I asking? What's the scale factor say? Take that distance and cut it in half. Take this distance and cut it in half. Do we know how to cut that in half? I hope so, from earlier in the year or multiple times during the year. Tell me how to use my compass to cut that distance in half. Put it on point R and you take it from here. Open up more than halfway. You're darn right back there. Make a decent size arc, almost a half circle. Leave your compass opening the same. Whoa, whoa, whoa. Before some of you go back to that straight edge here. Go to point O. Make sure, how many points of intersection should I have with these two arcs? 2 points of intersection. Now here's why I say hold up grabbing your straight edge. Now, could you just line up your straight edge, draw the line through? Yeah. It's good. Remember, you got to do this from point A and from point T. So you're going to have a lot of markings on there. So how about let's eliminate the number of markings we have. Line up your straight edge, but instead of just drawing the darn thing through, what's the only place I'm concerned with? Where it intersects RO. So I'm just going to put a little point there, and there's O prime, R prime. All right, it's one less construction mark, so 3 less altogether at the end. And now I'm going to do it for T and A. Here. All right, connect T to O, connect A to O. Bisect it. And then hopefully you notice a triangle that is smaller than ART. So go ahead and get rolling. Make sure never to have your image on the opposite side of the center. It should be on the same side as the center in the figure. Never on the opposite side. That's something totally different.
Mine does look kind of.
How's that triangle looking over here, fellas? All right. Getting smaller and getting closer to O. Don't get me wrong. In an honors level class, would I love to change the scale factor to 1/4 or 3/4 and see what you would do there? Yes, but time's sake, we do not have that time. All right. If I wanted a scale factor of 1/4. We need to bisect again, but to the left side now of our prime. All right, so I'll go 1/2 on you. Go ahead and finish up. And then the next one, now we're going to double our distance. How do I do a scale factor of 2 by using that compass? Go ahead and finish up. We got plenty of time. This is the last one. It's a triangle, Will, yeah. Yep, I don't need 3 vertices hanging out. How do you feel about that one vote, huh?
You sure you didn't know that?
I did not. I checked twice. Well, actually, let me check again. Nope, still no way. Yep, good. Someone's got it in for you. All right. That's cute. All right, here we go. Ready? All right, now how do I dilate by 2? Oh boy, look at that, everybody. Here we go. Look at that. Just 2 more. All right, let's take triangle ABC, dilate it by 2. Good news, though. Where's the center of dilation? Point B. Why is that good news? You don't have to do a darn thing. B prime is going to be right where B is, invariant. The only thing we need to move is A and B, A and C. So how do I move them by a scale factor of 2? I'm doubling the distance away. So right now, B and A have a distance. Let's double it. Let's extend side BA. Extend it. And then using your compass, measure the distance from B to A. So I can double it. So I'm going to take B to A, measure that distance with my compass. And now how do I double it? Where do I move it? Now I move it up to A. That's a certain distance. Let's double it right there up to A. Make a little mark on my extended side. And there is A prime. And do the same thing for B. C, extend BC. Take my compass, measure the length of BC. Put my compass on C and figure out where C prime is again. And there's C prime. Connect them. And are the two similar to each other? Yeah. Pretty much the same statement that we wrote previously. Dilations are not rigid motion, so don't even write it. Dilations preserve angle measure. And who am I opening up this up to? Last three. Your word?
Henceforth.
All right. Yes. Henceforth. Triangle ABC similar. How many put congruent? Stop. Stop. Similar. All right, good work. Keep grinding. Just go right in it. Keep going.